Hi, this is Rong. Today I want to talk about proof by induction. And this is my topic. My topic is topic 4. To I want to prove the left side equation equal to the right side. And here is my name, and this is my Drexel email address. Here I want to talk about what is proof by induction. Mathematical induction is a special way of proving things. It has only 2 steps. Step 1. Show it is true for the first one. This sentence means we need to prove the base case of this equation. In this case, the base case is k equal to 1. And also, for the right side, the base case is n equal to 1. And step 2, we need to show that if any one is true, then the next one is true. This sentence means we need to prove k is when k equal to n, and n can make these equations true. And then we also need to prove when k equal to n plus 1, and the n plus 1 can also make the equation is true. Basically, this is the logic of how to prove the induction. And if then the step 1 and step 2 is true, then all of this equation is true. And here we want to prove these equations through these 3 ways. These 3 ways is just like what I'm talking about. The state the base case. This one is just to let everyone know what is the base case, and the second one is prove the base case, and the third one is state the inductive hypothesis. So we will go through the whole 3 steps to prove this equation is true. So first we need to state the base case. What is the base case? As I told before, the base case is when k equal to 1. And here I want to prove the base case. When k equal to 1, the left side of this one, of the equation, is equal to 1 multiple 1 plus 1 is equal to 2. And the right side is 1 multiple 1 plus 1 multiple 1 plus 2. This equal to 6, and 6 divided by 3 is equal to 2. And the left side equal to right side. So the base case is true. We just prove the base case of the whole equation. That's true. And after that, we need to prove state the inductive hypothesis. The inductive hypothesis just need to let us to figure out when k equal to n, and is this k equal to n make k equal to n plus 1 true. So first, we assume k equal to n, and the whole equation about k, about when k equal to n is true. Then we have the 1 multiple 2 plus 2 multiple 3 plus 3 multiple 4, and plus so on until n multiple n plus 1 equal to n multiple n plus 1 multiple n plus 2 divided by 3. We just assume when n equal to k, this equation is true. Now we want to prove when k equal to n plus 1, this is true. If we can prove this n equal to n plus 1 is true, we can just make the inductive hypothesis true. So the left side is 1 multiple 2 plus 2 multiple 3, and plus 3 multiple 4, and until the end of this equation. We just simplify the equation. First, we have n. First, because we have n, and because this part is just 1, it's just n equal to 1 until n equal to n, k equal to n. So we can just replace this part to this equation. So we have n multiple n plus 1 multiple n plus 2 divided by 3 plus n add 1 multiple n plus 2, and we simplify the equation to this one. Then we have the final equation n plus 1 plus n plus 2 and multiple n plus 3 divided by 3. And the right side, we have n plus 1 multiple n plus 2 and multiple n plus 3 divided by 3. So in this case, the left side and the right side is equal. We prove the when k equal to n plus 1, when k equal to n is true, and the k equal to n plus 1 is true. And after that, we prove the base case is true, and the k equal to n and the k equal to n plus 1 state is true. So we prove this whole equation is true. And thank you guys. Thank you for watching. This is a reference.